In this video, I'll show you how to find the standard deviation and variance for population data. Our formula for the standard deviation for a population is sigma. The Greek letter sigma represents standard deviation because it's like an S. And the formula is that it's a square root of x minus mu squared, and then you add all those together, over n, the number of values in the population. This formula has a number of components and it can look quite complicated. But the first thing I want to point out is that you actually need mu, the mean, in order to do any calculations. This is a data set we've already worked with in the last couple of videos. If you remember, when we added up these values, they added to 36, and because there were 6 values in all, we know that the mean mu we calculated was 6. The first thing that you'll do for this calculation, according to BEDMAS, the order of operations, is you have to calculate what's in brackets first. And what the x means here is every single value minus the mean. So the first step is to take every single value in the table and subtract the mean 6. So for example, 10 minus 6, my first value would give me 4. 5 minus 6 gives me negative 1. 7 minus 6 gives positive 1. 6 minus 6 is 0. 7 minus 6 again is 1. And 1 minus 6 is negative 5. These are what are called deviations from the mean. And the reason that they're called deviations is that your mean acts like a perfect balancing point. So if you actually add together the difference between each number and the mean, all of these deviations, 4, minus 1, plus 1, plus 0, plus 1, minus 5, they'll always add to 0. If they don't add to 0, it means you made a mistake somewhere because the mean has to be your perfect balancing point. If it isn't, and you've made a mistake somewhere, then you'll get an answer other than 0. So it's always good to check those, that all of these deviations, as they're called, add up to 0. It helps to prove that you're on the right track. The next part of the formula says that you take the thing in the brackets and square it. According to BEDMAS, we do brackets first, then exponents. So we're going to have to take each of these deviations we calculated and square them. So I knew 10 minus 6 was 4, so next I'm going to do 4 squared. That will give me 16. Negative 1 squared is positive 1. 1 squared is 1. 0 squared is 0. 1 squared is 1. And negative 5 squared again would be 25. So what I have to do now is, according to the formula, we found the deviations. That means every value minus the mean. We squared them. The reason that we square them is because if you just tried adding them together, like I mentioned, they all add up to 0. So by squaring them, it will actually ensure that you can't have any negative values and they can't cancel each other out. Notice that any negative number squared will turn positive. So squaring just makes sure that they don't all perfectly cancel and we can actually get a calculation for how far away these values are from the mean. That's our whole goal when capturing a measure of spread. We want to see how far away the value is from the mean. So the deviation, x minus the mean, told us how far each one was. But because the mean is a perfect balancing point, if you try to capture that for every single value, since the standard deviation is supposed to give us information for every point, when we add it up for every point, it adds to 0 because the mean balances it. So by squaring it, we get rid of the negatives, and then everything doesn't cancel out. We can actually add them all together. 16 plus 1 plus 1 plus 0 plus 1 plus 25, that will actually give you 44. So if you want to find the standard deviation, this whole complicated looking thing on top just means 44. We found the deviations, we squared them, we added them all together. That's what this means. The sum symbol here means add them all up. Then you're going to divide by the number of values we started with, 1, 2, 3, 4, 5, 6, and take the square root. I'll pull up my calculator again. 44 divided by 6 is about 7.33333, and then I just need to take the square root of that number, and I get 2.708, and that is your standard deviation. If you want what's called the variance instead, the variance is just the standard deviation squared, or the number that's inside of this square root, the 44 over 6. That's the variance. It's the number before taking the square root, 7.33333. So that is how you calculate the standard deviation and the variance for population level data. This is the formula that you use. The important note here is that the variance will be in the original units squared. So for example, if these all represented a number of minutes, the variance would be in minutes squared, which is a little bit hard to understand and work with, whereas the standard deviation would still be in minutes, the original units. So the standard deviation is preferred because it keeps the original units, and that's actually why you have to take the square root, so that you're not dealing with units squared. It can be a little bit tricky to use these formulas the first time, so we're going to do another example in the next video.